So far we've only drawn a production possibility frontier that's a straight line, and I'd like us to be a little bit more sophisticated and think about this assumption of a straight line production possibility frontier. And so I'm going to change our story a little bit, and in particular I want us to think about what happens if as Robinson Crusoe catches fish, catching fish gets harder and harder. So you could think in your mind about various reasons why this might be the case. Maybe as he catches fish, he's depleting this natural resources of fishing, and so there are fewer fish in the pond, and so it takes more of a candy bar to catch the still remaining fish. It might be, I don't know, maybe he gets tired the more candy bar he uses for fishing, and he gets distracted, and the fish come and they grab a piece of candy bar without him noticing. Whatever the reason is, I'm changing our story a little bit, and I'm assuming that as he uses candy bars for fishing, it gets harder and harder to catch fish. And what I'd like us to think about is, what does this imply about the opportunity cost of fishing? And what does this imply about the shape of the production possibility frontier? So I asked you to think about what the production possibility frontier would look like if Robinson Crusoe found that the more he fished, the harder and harder it was to catch fish. In other words, the first candy bar maybe he could catch 10 fish, but with the second candy bar he could only catch fewer fish, maybe 9 fish. And I'm sure many of you realized that in this case the production possibility frontier would look something like this. In other words, in this case the production possibility frontier is the familiar shape of a production possibility curve. Let's see how this curve illustrates the fact that fishing gets harder and harder. If we look at the slope of this line, we can see that in the beginning, each candy bar that Robinson Crusoe uses, he gives up 5 birds, but the reward is a relatively high reward of maybe 10 fish. Later on, with each of the candy bars that he gives up, in terms of birding, he gives up the same number of birds, 5 birds, but the gain in terms of fish is much smaller. Maybe he only gains 2 fish. So what is the slope of these two lines? Or again, what is the absolute value of the slope? So for this first segment, the absolute value of the slope is 5/10, or 1/2. And we can see that over here, the absolute value of the slope is 5/2, or it's equal to 2.5. In other words, we can see that as we move down the production possibility frontier, the opportunity cost of whatever is on the horizontal axis, in this case the opportunity cost of catching a fish, in terms of whatever is on the vertical axis, which in this case is birds, the opportunity cost is increasing. So as we move along the production possibility frontier, the cost of fishing in terms of birds is getting higher and higher. So let me leave you with another question, and the question is as follows. Suppose I changed my story, and instead of telling you that as we catch more fish, fishing gets harder and harder, suppose I told you that as we catch more birds, birding gets harder and harder. So with each candy bar we could still catch 10 fish, but as we use the candy bars towards birding, birding becomes harder and harder, and we catch fewer and fewer birds. What would my production possibility frontier look like in such a case? So draw the same graph, again put fish on the horizontal axis, and put birds on the vertical axis, and draw that production possibility frontier.